this is the one I got the most questions about, and it's the one that when I looked at people's progress on the homework, it's the one that people missed the most frequently, was one like this. There's kind of a lot going on here. Can I start to isolate a variable yet? Thumbs up or down? I can't, because I can't point to what? I can't point to a single variable, can I? There's a bunch of variables sprinkled throughout there. So I've got to simplify first. So let's focus on the simplifying. What do I have to do first to simplify? I'm just working regular PEMDAS, so I'm starting in parentheses. Do I start in the inner parentheses or the outer? I start on the inner and work my way out, right? But if I look at the inner parentheses, the red ones, there's nothing to do inside those, right? Then I do the outer, right? So the red ones, there's nothing to do. So now we'll move outward and we'll focus on the next layer of parentheses, which are written as brackets here, the blue ones. Well, what could I do inside the blue brackets there? What would I do first? Yeah, I'm going to multiply, aren't I? What's that mean? Jubal, what's that mean? What am I going to do here to simplify? What would I do? I've got to simplify the stuff inside those brackets. Distribute. Yeah, multiply means distribute, doesn't it? So what am I distributing, everybody? The negative 4. There you go. I'm going to distribute the negative 4 to both parts. And what's that give me then? I get 2 times 7. What do I get when I distribute the negative 4? Plus 4n. There was another common mistake. People, when they distributed a negative, they forgot to change the sign and make a negative times a negative positive. Okay? On the other side, same drill, right? What am I distributing first? The 4? The 6, because I'm working inside the parentheses, right? So inside the parentheses, I'm distributing that 6 and getting what? 6n plus 6, and then I have another minus 3n there. Okay, what's the last step inside parentheses or brackets? What do I need to do in this first? Add like terms. Yep, I can add the 7 minus 4, right? So I end up with 2 times, I'm just going to make those parentheses, 3 plus 4n plus 7n equals negative 16 plus 4 times, same thing here, right? What terms could I combine in the second? There you go, right? The 6n and the 3n, right? So 6n minus 3n is just 3n. There you go, perfect. Plus 6. Okay, now we can move down. We're outside of the parentheses, so we're just going to work our way down. No exponents, multiplication or division, anything I need to multiply or divide. Okay, good. Now I'm going to distribute over that blue quantity. Good. Good. So the next step would be this kind of thing, right? I'm going to distribute that 2. I'm going to distribute that 4. And that gives me 6 plus 8n plus 7n equals negative 16 plus 12n plus 24, right? Last simplification step? Combine like terms. Good. Okay. So those guys would combine to a 15n. Here I've got 12n. Negative 16 plus 24 is just 8. Point with your fingers. Which direction am I going to push the ends? To the right or the left? Most people are pointing to the left. I agree. How come? Okay, I mean, it would work either way, but we want a positive number of ends, positive coefficient. Good. It's good. So we're going to subtract 12n to get rid of those. Okay, if we're pushing the n's to the left, what else could we do here, combined steps?
The 6 and the 8.
Good, numbers go the other way, don't they? Perfect. So now we're going to subtract 6, cancel those guys, and that's going to give us 3n equals 14. Oh, 2, sorry, what am I saying? Yeah. Whoops, how about 2? Okay, last step to isolate n. Yeah, divide by 3, good. And we got it. N equals 2/3. Good stuff. Okay, lot of moving parts there, right? Okay. All right, now today, what I want to focus on today is applications. So we don't do a ton of this, really in high school, and I don't think we should focus too much on it because what we really need to do is work on our math, right? We need to develop our math skills so eventually we can apply math and do important things with it. My background, I was not a math major. I was a physics major, which is mostly math. But physics is mostly about applying math to solve problems. Like, for example, if I were shooting let's say I was shooting a cannonball, and I knew the angle of the cannon, and I knew how fast the cannonball was leaving the tube, I could use physics to make an exact prediction of where the cannonball is going to land, right? So I would use math to do that. It would boil down to a bunch of math models and equations, but that's eventually what we do with math. We use it to make predictions about the world, about the economy, all kinds of things. The first steps we can take towards being able to do that is just kind of practicing thinking about how to do problem solving with math. These are not going to be really super tough problems. Once we get to the part where we're doing the math problem, they're typically very simple problems. The tricky part, though, and I think you'll agree with me, is not doing the math, it's converting from words or a situation into a math equation, right? That's the part that takes a little bit of thought and that we don't practice very much. So that's the kind of stuff we're going to focus on. Now, if we want to break this down, anytime you're talking about an application or a word problem, there's really 4 steps that I think we could boil this down to. There's a strategy here we're going to use. Now, don't think the days are gone in math when you got one simple recipe and all you had to do was just, plug in numbers and you didn't have to do much thinking. Every problem is going to be different from the last when you're doing these applications. There is no one-size-fits-all recipe, but the strategy is going to be consistent. So what is this? Well, the first step, and don't underestimate the importance of this, is just to understand the problem. How many times have you're trying to remember a name or you're trying to think of something and you just can't do it, and then as soon as you stop consciously trying to remember the name, what happens? You get it, right? As soon as you relax your thinking and you move on to something else, your brain's able to do that. That is really an important concept. I mean, I'm going to talk a lot about brain science this year because I think one of the things we don't do enough is talk about just the process of learning. We focus so much on the content that we don't always think about how do we use this amazing brain that we have most effectively and most efficiently. And one thing that's important to understand is your brain does most of its thinking subconsciously. There's this illusion that we think that conscious thought dominates all our decisions. It really doesn't. Most of the time they're subconscious. So you have to let your brain have the opportunity to sort of relax and think subconsciously about things. Now, part of that is you can't just read something once and assume that you're going to completely understand the problem. You got to read it and reread it, maybe make a drawing if possible. The further you go in math or in applications of math like physics or engineering, the more this is important. My son's he's a senior in college this year, but his freshman year, I remember he told me a story where he was in his first really tough math class, college math class, and he had this problem. He had a problem set with only 3 or 4 problems, but one of the problems, he had no clue how to begin this thing. He literally told me he sat there and stared at that thing for 3 hours, didn't write anything down. He just thought about it, and eventually, his brain kind of came up with a strategy, and it turned out that he was able to get some traction with that, and it worked. But I'm not suggesting that's going to happen in a high school Algebra 2 class. 3 hours probably is not going to be required, but maybe 5 minutes might be, right? Sometimes you got to just be patient and give yourself a chance to digest the problem and think about it, and your brain will do amazing things. So part of this first step then is also assigning variables. Now, for now, it's only going to be one variable. Later in the year, we'll have to assign more variables when we talk about solving systems of equations. But for now, we're going to try to pin this down to a single variable. And I literally want you to write down on your paper, x equals, or whatever your variable is, probably x. Why not just make it x? X equals what in this problem? What is it representing? That's really important to do. And we'll look at an example in a second. So we're going to understand the problem, identify the variable, make a drawing. If it's a geometry problem, if I can possibly make a drawing, that helps. What's next? Next is the step where we're going to translate from words into math. And that's the part that probably requires the most practice. Once we do that, we're going to flip into algebra mode, and it's automatic. You just do the algebra, which you're good at and you're getting better at. You do the math, you come up with a solution, and that part is pretty robotic. It's pretty easy to do, right? The more math you do, the easier that part gets. The very last step is you've got to flip out of algebra mode and back into application mode, the context or the word problem. And you got to say, okay, I got this math solution. What does that mean in the context of the original problem, right? And interpret that, okay? Give me 1 to 5 on that. Does that make sense how that approach could work? Okay, let's try it. Let's try it. How about something like this guy? A new television set was recently purchased for the common room in a residence hall for $449.40, including tax. So we're at a little disadvantage here because we don't have sales tax in Oregon, but I'm sure you all know how that works. If the tax rate is 7%, find the price of the television set before taxes. Okay? Read through that once or twice on your own. Okay. First thing we want to do here is identify what is the unknown or the variable here. What are we trying to find and what we don't know at this point? The price before tax. Okay, so we're going to call that X and we're going to write that down. I know this might seem unnecessary, but writing that down is so important because then when you're going through the process of trying to convert this into an algebra equation, it's right there in front of you. You can always look back and be reminded what that variable represents. Okay, so let's think about this a little bit. How does sales tax work? If there's a 7% tax on something, like let's just say use a specific example. If something costs $80, how would I calculate before tax? If that's the amount the sticker price says in the store, how could I calculate how much tax I'm paying if it's 7%? So, okay, so I'm going to multiply by what, 7? Okay, good, because anytime I want to do a calculation with a percent, I have to convert it to a decimal, right? So I'm just going to convert that to 0.07, and I would just multiply the original price by 0.07 to find out how much tax I have to pay extra, right? Everybody agree? So then I'd have the original amount plus the extra tax, right? Should equal the amount that I pay. Okay, well, let's see if we can convert this into an equation. It says it's purchased for a common room, it's purchased for a total of $449.40 after tax, right? So shouldn't that be what my equation is equal to? Everybody get that? Okay, so we know that this is going to be equal to, my equation is going to equal 449.4. Okay, that's the price after tax. How do I calculate that? It's the original amount, which is what? What's the original price, sticker price? It's X, right? That's what we wrote down. It's X plus the tax. And what's the tax? How do I say 7% of 0.07? Yeah. Now, our example was 7% of $80, but what are we taking 7% of here? X, right, of the price before tax. Whatever the sticker price is before tax, we're going to multiply that by 0.07, right? Everybody agree? Okay, that's pretty good. Look, now we can shift into algebra mode. We converted the application or the word problem into a math problem. We can just forget about the words and go to work on the algebra. So can I point to a single X? I don't think I can yet, can I? I've got two terms, right? So what do I have to do before I can solve for X? Combine like terms. What is X plus 0.07X? Well, what's the coefficient of X here? 1. Okay, so 1X plus 0.07X is 1.07X, right? Like what if that were 2X plus 3X? You would all tell me that's 5X, right? Everybody agree? Because we're just adding the coefficients in that case. Well, so this is going to be 1 plus 0.07 times X. I'm adding up the number of X's. So all this stuff just combines to 1.07X, and that's equal to 449.40. Now, I would argue we maybe could have just started with that equation. How could we have jumped right to that equation? If I'm paying an extra 7% sales tax, what percentage of the original sticker price do I end up paying? 107%. I pay the 100% would have been the sticker price, plus the extra 7% for tax means I'm paying 107% of the sticker price. Give me thumbs on that. Does that make sense? Okay, good. Anytime you're paying more than 100% of something, it's going to be bigger, right? Okay, so there's our equation. Now it's easy. What happens if what do I do to solve for X? Divide. Divide each side by 1.07. And that ends up being, if I do that, that ends up equaling 420. So that's our math solution. We have to go back and see what does that mean in the context of the original problem. How do we interpret that? Well, that's what we were looking for, wasn't it? Was X. So the original sticker price before tax was $420. Okay. Always ask yourself, does that seem reasonable? Should the price before tax be a little bit less than the price after tax? Yeah, right? Makes sense. That seems reasonable, doesn't it? Okay. All right. Give me 1 to 5 on that. I wouldn't expect a lot of 5s. That's pretty good. I mean, I would expect, because this is a bit of a process. I mean, the idea here is, and honestly, this is how you always want to look at a class like an algebra class, where it's very conceptual, there's a lot of analyzing going on, very analytical. You always want to try to just get to a point where you get it, or you at least sort of get it, right? That's the whole point, is you want to try to get to a point where you're saying, okay, I see what's going on. And then later on, you can go back and get there much more easily. Once you've constructed those pathways in your brain, they're there, and you can always go back and find them again, right? Each problem is going to be a little different, though. But every time you do one of these, it's going to help. Okay, what about one like this? This is a good one because, well, you'll see why. One number is 7 times a first number. A third number is 100 more than the first number. Write an expression for the sum of the numbers. And there are 3 numbers there, right? So I want to be able to come up here and I want to be able to identify what I need to use variables to write expressions for the first number and the second number and the third number so I can add those up, right? Okay, so could I do X, Y, Z? And the answer is yes, but I don't want to. That's a great idea, and we could do it, but here's the disadvantage of that. If I call the first one X and the second one Y and the third one Z, the fundamental theorem of algebra, which we'll talk about later in the year, tells us this, that I need at least as many equations as I have unknowns or variables. So if I write this in terms of 3 variables, that means I've got to have at least 3 equations in my system, and that's starting to sound more difficult, right? So we would prefer, if we could, to always write these in terms of 1 variable. Eventually we may not be able to, and we'll deal with that later in the year, but for now we could. We could write these in terms of a single variable, which we'll call X. Now, which number would I call X? The first number. How come?
Because the second number is 7 times that.
Okay. Let me paraphrase that. That's a great answer. The first number would be X because that's the one we know nothing else about. Anybody get that? The other numbers, they give us some information about in terms of that first number, right? But the first number is the one we know nothing about, so that's the one we are going to call X. Okay, what about the next number, which we'll call the second number? Yeah, if one number is 7 times the first number, then that's just going to be 7x. We'll call that our second number. What about the third number? There you go. I'm just going to write it as x plus 100, but either way, right? Either one is fine. Okay, give me thumbs on that. Does that make sense? Look at that's great though, because now I've only got a single variable there. So if I want to write the sum of those numbers, what does sum mean? Add them up, right? So if I add all those numbers up, what do I get? Well, that's just going to be x plus 7x, whoops, plus x plus 100, right? Can I simplify that?
Yeah, you can combine that.
Combine like terms, can I? Yeah. So what if I combine the x's? How many x's do I get?
3. Oh, 9.
Everybody agree? 9? 1x plus 7x plus 1x, 9x, good. 9x and then plus 100. Okay, what if this problem were a little bit more extensive? What if instead it had asked us to do that stuff? It told us that information, but it said that the sum of the 3 numbers is 757. Find the numbers.
Well,
Equals, there you go, right? Equals, wouldn't that make sense? Is 757, oops. Is 757 just means equals 757. So now I'd have the sum of the numbers, which was 9x plus 100 equals 757, right? Okay, now that's pretty good. Now I've got an equation with a single variable. What are the 2 steps in order to solve for x? Subtract 100 and then divide by 9. There you go. So we would get 9x equals 657. If I divide by 9, what do we get? Well, we get x equals, and now 9 doesn't go into 6, but 9 goes into 65 7 times with 2 remaining, right? 9 times 7, 63. 9 goes into 27 3 times. So x is 73. Are we done? Right? Circle that answer.
have to times it for the next.
Ah, there you go. That's our algebra answer, but the last step is we have to go back, we have to go out of algebra mode back into word mode, into the context. So the first number, x is 73, so the first number is 73. Second number, I'd have to multiply that by 7. Yeah, 511, there you go. And the third number would be 173. Very good. Okay. What do you know? Those are our 3 numbers. Okay. I'm going to stop That's a lot for today. So the assignment is up there. Why don't you jump in and just practice this a little bit, and then we'll go back and look at an example or two tomorrow, and I'll let you work some more tomorrow.